Hi, this lesson will be Inequalities, page 116 to 127. So let's get started. Okay, so here we are talking about inequalities. This is page 116. So I'm going to do some problems from different pages throughout the packet. So let's start with number 1. And if we go all the way down to here, it says for each inequality, circle any allowed value for the variable. 2 problems are done as examples. So looking at row 1, we can see that we have the first one done for us. It's saying that M, let me grab my little spotlight here, M is less than 7. So the open mouth of an inequality always points to the bigger number. So for example, if I have, let's go over here and write 10, not letting me write, there it goes, 10, and then I have this symbol, and then I have 16. And the dots shouldn't be in there. Get rid of those dots. So this is saying 10 is less than 16, which you intuitively know. However, always think of it as this Pac-Man guy. The mouth eats the bigger number. So if I was to write it this way, this is red, 16 is greater than 10. The first one is red, 10 is less than 16. So the less than symbol is this way. The greater than symbol is that way. So don't let that confuse you. If they put a line underneath, for example, if they did this and they put a line underneath it, that means greater than or equal to. So it includes the number. This way is less than or equal to. Or this first one is less than, this is greater than. So it'll look more, it'll be easier to tell when there's numbers in there. So let's go back to 1A. So M is less than 7. Notice how the open mouth is open towards the 7, which is the bigger number. So we have to pick all the numbers in the row that are less than 7. So they've circled -3. That's less than 7. They've circled 0. And they've circled 5. Notice how they didn't circle 7 because it says less than. It doesn't say less than or equal to. And obviously 9 is bigger than 7, so that wouldn't qualify. And 14 is also bigger than 7. Look at letter B here. We have N is less than 10. N is less than 10. Again, the open mouth is eating the bigger number. It's eating the 10. So let's pick all the numbers that are less than 10. So -2 would qualify for that. 0 is less than 10. 3 is less than 10. 7 is less than 10. 10 is not less than 10. It's equal to it, so we won't circle that. And 15 is greater than 10. So we would circle 4 in that row. Let's look at number 4A. 4A. So let's clear this and go to, 4A at the bottom here. It says X is greater than or equal to 14. Why did I say equal to 14? Because the little line is under the greater than sign. So X is greater than or equal to 14. So now we got to find all numbers that fit that criteria. So -6 is not greater than or equal to 14. 0 is not greater than or equal to 14. 2 is not greater than or equal to 14. How about 17? Yeah, 17 is greater than or equal to 14. What about 29? Yep, 29 is greater than or equal to 14, and also 41. What if I said 14? Would 14 fit the criteria for our inequality? Yes, because it says X is greater than or equal to 14. So we would then also circle 14. Okay, let's look at B. It says Z is greater than or equal to -4. So now we got to think of numbers greater than or equal to -4. So we look at -9. Is that going to fit the criteria? No, because -9 is further to the left on the number line of -4. So we need numbers to the -4 or to the right on the number line. So if I had the number line here, I might as well draw it for a second. Here's my number line. And here is my 0. And then we have numbers on this side. The farther from 0 you get, the more negative the number, the smaller the number. If you think of it in terms of temperature, -1 is a warmer temperature than, say, -4. So if you keep going, and I go to -5, etc., down to -9, which is the first number in our series there, you can see that -9 is to the left of -4 here. So -9 is smaller than -4. So I would not circle that one because we need numbers greater than or equal to -4. -5 would also not fit the criteria because -5 is less than -4. It's a colder temperature if you think of it that way. -4 would fit the criteria because it is equal to -4. -3 would also fit the criteria because -3 is greater than -4. 0 is greater than -4. Those numbers are all to the right on the number line of -4. And then +4 is also greater than -4. So those would be the ones that meet the criteria on that one. Okay, let's go on to, I want to do page 117, number 2. So let's scroll down here. So if you want to turn to that page, way at the bottom here, circle the letter of for the inequality graphed on each number line. So you'll see here, we have an open circle here at +1. The arrow is going to the left of +1. So we know that we want to include any values that are on our arrow. The open circle here means that it does not include 1. If the circle were closed, then we would say that the values also do include +1. But since we have an open circle, and I'll make that a little bigger so you can see it a little better, it will not include 1. So we have to look below at our choices. So we have r is less than 1, we have r is less than or equal to 1, and we have r is greater than or equal to 1. Well, we know that the arrow is going to the left, so we don't want numbers greater than 1. So let's cross that one off. Now we just have to decide, do we want numbers less than 1 or numbers less than and equal to 1? Well, the open circle tells us the answer. We don't want them to be equal to 1, so that crosses that one off. So the correct answer is A. Okay. Let's go on to page 118. I want to do number 5. Okay, graph the inequalities. So now they're giving you the inequality symbol there, and they want you to graph it. So what does this say here? How would you read that? Remember, the open mouth goes towards the bigger number. X is greater than -2. Correct. So does it include equal to -2? No, it would have to have a line under there, right? And it does not. So it's not going to include -2. So that's going to be an open circle at the -2. So we're going to put an open circle there. And then X is greater than -2. So which way will our arrow go if we want to include numbers that are bigger than -2? Right, to the right is always getting bigger. So we're going to include all the way to the right. So that's how you would graph number 5. Let's look at number 7 as the next one. Same page. Scroll down a little bit. So now we have n. Well, how would you say that? N what? N is greater than or equal to 0. So this time it says or equal to. So we're going to put a closed circle at 0. And then we have to have numbers greater than or equal to 0. So that's going to be to the right again. Yep. So we're going to go this way with our graph. So that's how you do that one. Okay, let's look at page 120. So that's the next page. Nope, it's after the next page. The next page here is just instructions. Go to 120. So I want to do number 1. So let's solve each inequality. So when you solve inequalities, you pretty much are doing the same thing as you would when you're solving equations with an equals to instead of an inequality greater than or less than sign. So for instance, this first one is 2x plus 6 is greater than or equal to 10. So if this wasn't an inequality sign, if this was just an equal sign, you would solve this the same way as if it were an equal sign. So you want to get the variable by itself. So the first step is to add or subtract anything that's added or subtracted from the variable term. So our variable term is 2x. So we see that there's a plus 6 added to 2x. So we are going to do the opposite of adding. We're going to subtract 6. And whatever you do to one side of the inequality, you also do to the other side. So we're going to subtract 6 from the other side as well. So if we do that, we can see that our 6 minus 6 is going to cross off, leaving us 0, which is what we want. And then we are going to see that our 10 minus 6 is 4. We're going to keep our inequality sign in between that. And what we're left with on the left side is just 2x. Now we are going to get rid of the coefficient in front of the x because our goal is to get x by itself. So to do that, we can see that 2 is being multiplied by x. So we do the opposite of multiplying. We're going to divide. So we're going to divide by the 2. Whatever we do to one side, we do to the other side. And then you'll notice that the 2's on the left side will cancel each other out to 1, leaving us with just 1x or x. And on the right side, when we solve that, it's 4 divided by 2. So we're going to be left with x is greater than or equal to 4 divided by 2, which is just 2. So we have solved the inequality. All values that are greater than or equal to 2 should yield a true statement. So let's test that out. Let's give it a try. So if we take, so let's just draw this first of all. So if this is our number line and x is greater than or equal to 2, if this is our 0 and this is our 1, this is our 2, and then 3, and we could keep going if we wanted to 4, 5, 6, 7, 8, all the way to infinity. We are going to make a closed circle at 2. Why closed? Because it includes 2. And then our inequality is going to go to the right because we want numbers greater than 2. So it's going to go out that direction. So let's pick a value that is in our field of values that work. So let's pick 4, for example. Let's choose 4 because that's on the side of our arrow. So if we pick 4, we're going to plug it in for x in our original value. So we have 2x, but instead of x, we're going to put 4 in there, plus 6 is greater than or equal to 10. And when you're taking your AccuPlacer test and you have an inequality like this and you solve it, you can check your answer by doing this. And if your answer yields a true statement, then you've got the right answer. So let's solve this. We do multiplying first. 2 times 4 is 8. 8 plus 6 is greater than or equal to 10. So what is 8 plus 6? 14. So is this statement true? Is 14 greater than or equal to 10? Yes, it is. So we know that we have the correct inequality solution. We could try 2 because it says it should include 2 and still make a statement that's equal. So let's try that one. So let's put in 2. Just undo all this and try 2 this next time. Okay, let's put 2 in there instead because it says that 2 should also work. So 2 times 2 plus 6 should be greater than or equal to 10. And if we do 2 times 2 is 4, we get 4 plus 6 is greater than or equal to 10. Is that a true statement? 4 plus 6 is 10. Is 10 greater than or equal to 10? Yes, because 10 is equal to 10. So that value also works in our solution. Okay, let me clear this. And I wanted to do 4b for you. So we have 3/4 n plus 3 is less than -3. So let's make a little bit of white space here. Let's get a little bit of writing room. So the one I'm doing is 3/4 n plus 3 is less than -3. Okay, so we want to solve for n, get n all by itself. First thing we're going to do is add or subtract anything that's added or subtracted from the variable part. Well, the variable part is 3/4 n, and 3 is added to that, so we are going to subtract 3. Whatever we do to one side, we also need to do to the other, so we're going to subtract 3 on the right side as well. So let's do that. So on the left side, we are given 3 minus 3, which should then cancel itself out to 0, which is what we want. And then on the right side, we get, be careful on this one, -3 minus 3. So we're at -3 on the number line, and we're getting 3 more negative. So if I was to draw the number line here, well, that's a bad number line. Let me undo that, make it a straight line. So if this was my number line here, and this was, let's say, 0, and this was -1, this was -2, this was -3, and I would keep going, and let's say this is -6 down here. I'm just skipping numbers in between for sake of time. So if we're at -3 to start with, let me get a different color here. And I have to go 3 more negative. I have to go which direction? To the left. So I have to go 1, 2, 3 more negative. So that'll land me on -6. So -3 minus 3 is -6. Okay, so now I can put my inequality sign back, and now I'm left with 3/4 n is less than -6. So now 3/4 is being multiplied by n. I have to get rid of that 3/4. To get rid of 3/4, I would divide by 3/4. But if you remember from fractions, when we did that in the curriculum, when you divide by a fraction, you really are multiplying by the reciprocal. That's the keep, change, flip method. You keep the first number, you change the sign to multiplication, and you flip. So let me just explain how that would work. So if I was to divide by 3/4, which is what I want to do, that's the same as doing 3/4. Let's just show you for a second here. 3/4 divided by 3/4, right? And using keep, change, flip, we get keep the first number, 3/4, change the sign to multiplication, and flip only the second fraction. So that would mean the 4 goes on top and the 3 goes on the bottom. That's the reciprocal. But notice what happens when I do this. The 4's cancel out and the 3's cancel out. So I'm going to make a shortcut so we don't have to think about all that. And I am going to, instead of dividing by 3/4, I am going to multiply, and it might erase my white line here, but let's just see. I'm going to just multiply by 3/4 instead. And I got rid of my nice white box there, but that's okay. So instead of dividing by 3/4, I'm going to multiply by, well, actually the reciprocal, 4/3, because that's what I'm doing anyway. So I'm eliminating all those extra steps in my head, and I'm just multiplying by the reciprocal. So if I multiply by the reciprocal on the left side, I'm going to multiply by the reciprocal on the right side. Notice how -6 times 4/3 is the same as -6 divided by 3/4. So now my 3's cancel out, my 4's cancel out, and I'm just left with n on the left side. N is less than, and now I got to solve this part over here. So I've got some canceling I can do. So -6 and a 3, they will cancel. So if I put the 3 into -6, I get -2, because 2 times 3 is 6, and the 3 will cross itself out. So now I'm left with -2 times 4, which is, right, -8. So the solution to this is n is less than -8. Now, let me erase all this and let's test that to see if we've got that correct. So let's just get rid of all of that except for the solution. Remember, this is the solution to 4b. And I think I'll rewrite that so that it's not over our, well, I'll just do this. There. So we're doing this one right here. So the solution is n is less than -8. So let's draw a number line and graph that. So we will start with 0 here, and then we'll go by 4s, -4, -8, -12, and then we'll go -16. And we could go farther, but you'll get the point. So n is less than -8, so we're going to have an open circle at -8. It does not include -8. And our arrow is going which direction? Left or right of -8? Yeah, less than. So less than goes to the left. So that would be our solution set. Now we can test it to see if our solution set is indeed true, if we got the right answer. So let's test it. Let's plug a value that should work into our equation. So let's try -12. So 3/4 times, we're going to fill -12 in for n, plus 3 is less than -3. So we do the multiplication part first. So we can cancel the 4 into the -12. That would become a 1, and this would become a -3. So then if we multiply 3 times -3, that'll give us -9, plus 3 is less than -3. So -9 plus 3 is, it's -9 getting 3 to the right, -6 is less than -3. Now that should yield a true statement since we are in our solution set, and it does because -6 is less than -3. Notice how if we tried -8 in our solution set, that should yield a false statement because n does not include -8. So you can try that at home if you want just to see that it works, but it is going to yield a false statement. Okay, so that's how you do that one. And then number 6, same page. Let's go down a little bit here. So this is something you're going to have to remember for the AccuPlacer because it's actually number 5, not number 6. And I wanted to do this one. So it's number 5. On the AccuPlacer, they are going to have one of these type of questions. And they're meant to trick you, but they don't have to. So let me make some white space here. Whenever you multiply or divide by a negative number, you need to switch or reverse the inequality sign. So you just got to remember that. Always think if I multiply or divide by a negative number, I have to switch or reverse the inequality sign. So that's going to be one of those trick questions that they're going to try to get you on. So 6 minus 2x is greater than 10. So first, I'm going to get rid of anything added or subtracted from the variable term. Don't let this confuse you because the variable term is second in our equation. That doesn't matter. So we have a positive 6. So we're going to get rid of that by subtracting 6. Do it to both sides. Whatever you do to one side, do to the other. So now my 6 minus 6 will cancel out. And I will be left on the left side with -2x. Don't forget there's that negative sign in front of that 2. It's right up here. Don't forget about it. Negative 2 is greater than 10 minus 6 is 4. Now I have to get rid of the coefficient, so I want to, it's being multiplied, negative 2 is being multiplied by x, so I want to divide by negative 2. Whatever I do to one side, I do to the other. And notice how now that I have divided by a negative number, I'm going to need to flip or reverse my inequality sign. So it's going to go this direction now, okay? Then the negative 2's will cross off, and I'll be left with my x on the left. And on the right, I will now have 4 divided by negative 2, which is negative 2. So our final answer will be x is less than negative 2. Notice that on the actual AccuPlacer, you're going to have answer choices. One of them will probably be x is greater than negative 2, in case you forget to flip or reverse the inequality sign. So don't forget to do that. So if we were to graph that, we can show that it's numbers that are less than negative 2, not including negative 2. So here's 0, here's negative 2, here's negative 4, etc. So we're going to put an open circle at negative 2, and our arrow is going to go to the left because it's less than negative 2. And if we wanted to test that and check that we did it right, we could pick a number within our solution set. So we could, for example, pick negative 4, plug it into our original equation. 6 minus 2 times negative 4 should be greater than 10. And if we get a true statement, we have done it correctly. Do the multiplying first. 6 minus 2, well, we can do negative 2 times negative 4, which is positive 8. So it's 6 plus 8 is greater than 10. And then we can say 6 plus 8 is 14. And 14 is indeed greater than negative 10. So that is a true statement. So we have solved our inequality correctly. Okay, let's clear that. Now I want to do page 121. And I want to do number 1. These can look a little weird at first, but they're not as bad as they seem once you get the idea of them. So our total is on the bottom. So that's our total. And our top is the, what you want to call the equation part. Okay. So they want us to write an inequality for what's pictured here. Well, we know the total is 24. And since it's an inequality, it's either going to be less than or greater than 24. So we have to look at the top. And we see that we have this little piece in here that's not identified. We don't know what that is. So we know that if we add x plus x plus x plus 3 plus the unidentified part, then that would be equal to 24. But since we don't know the identified or the unidentified part, we know that this part here, not including that little section that's not identified, has to be less than 24, because 24 is the total of all the sections. So then we just want to combine our like terms. So we have 3 x's, so 3x plus 3 is less than 24. So that's the inequality we would write. And then we would solve that by getting x by itself. So we would subtract 3 from both sides. The 3's would cross off. We'd be left with 3x is less than 24 minus 3, 21. We would divide by 3 to both sides. And our final solution, the 3's would cross off. We would get x is less than 21 divided by 3, or 7. So x is less than 7. Okay, we didn't have to divide or multiply by a negative number, so we didn't have to reverse the inequality sign. Okay, let's clear that one. Let's do number 4. Same concept. but now a little different because our total is still on the bottom. And on the top is our equation part. And if you look at it, this time the piece that we don't know, the unidentified piece, is this little part in the total. So we know that the top part is going to be more than the bottom part. So we're going to have to write this one as 2D plus D plus 5 plus 7 is greater than 36, because 36 is not the final total, it's 36 plus the unidentified part. And then we would just combine like terms to get our actual equation. So 2D and 1D is 3D, and then we would combine our 5 plus our 7, which is 12. So 3D plus 12 is greater than 36. And then we would solve the solution by getting D by itself. Okay. All right, let's look at 122. This is a longer packet. And I want to do 3A and 3B. John will be paid $35 for working Saturday. He will also be paid an extra $1.50 for each large poster he sells. So he's getting a straight pay and then a commission, so to speak. John's goal is to earn at least $85 on Saturday. Write an inequality, this is letter A, that tells how many posters N John must sell on Saturday in order to reach or exceed his goal. Okay, so if he wants to make at least $85, we're going to put 85 on this side. He wants to earn more than 85 or 85. So it's going to be, the amount he earns is going to be greater than or equal to $85. So now we have to put the equation here. So we know that he makes $35 just for being there. And then he makes an additional $1.50 for each poster he sells. So if he sells 2 posters, that's $1.50 times 2. If he sells 3 posters, that's $1.50 times 3. So we don't know the number, so we're going to call it N. So it's 150 times N. So that would be the inequality you would write. And then what is the least number of posters that John must sell in order to earn $85 or more? That's just asking you to solve the inequality for N. So let's go ahead and do that. So let's subtract 35 from both sides. And if I do that, these cross off. I'm left with $1.50 times N is greater than or equal to 85 minus 35, which is 0, and then a 5, so 50. Now I have to divide both sides by $1.50 and divide this by $1.50, and let's do that. $1.50 is crossed off, and I'm left with N is greater than or equal to 50 divided by $1.50. For sake of time, I'm going to just divide that on my calculator and cheat. But you won't be able to do that on the test. You're going to have to divide that. 50 divided by 1.5 is 33.33. 33.33. So the question is, what is the least number of posters that John must sell? So could he sell 33 posters? Now, don't get tricked by this. Could he sell 33 posters and make $85 based on our solution? No, right? That wouldn't be enough. He has to make a little, he has to sell a little over 33. He has to sell 33.33 posters, which is kind of nonsensical because you can't sell a third of a poster, right? Nobody'd buy that. So technically the correct answer then is he would need to sell at least 34 posters. If he didn't sell at least 34 posters, he would not make $85 at least. So he wants to make 85 or more. So he has to sell 34 posters. Okay, so you got to think through those a little bit. It can be a little tricky. So if on the AccuPlacer, if you have an answer choice that says 33, don't pick that. Okay, that would be the wrong answer. Okay, that one, I want to do 5A and 5B. Erica is designing a garden to be 54 feet long and no larger than 1,800 square feet in area. Write an inequality that describes the range of possible values for the width of the garden. So we know that area is multiplying length times width. So let me just make a little white space above here so we've got a little bit of room. So we have length of 54 and we have a width of W. So 54 times W, and we want the area to be no larger than 1,800. So it could be 1,800. That's why there's the greater, less than or equals to sign. And remember, it can't be any bigger than 1,800. So we're going to make this an equality. So that's letter A. And then to the nearest foot, what is the largest value W may have? So then that means solving for W. So we're going to divide by 54 to both sides. Cross off the 54s here. W, trying to make a W there, is less than or equal to, that's a terrible less than, hold on, I don't like that. Okay, make that a little better. W is less than or equal to, and then I'm going to cheat, 1,800 divided by 54. 1,800 divided by 54, 33.3. How do we get that again, huh? So we had on the last question, isn't it? I just want to double check that because maybe I still had my other numbers showing up in there and I just want to make sure. Nope, it's 33.33. So to the nearest foot, what is the largest value W may be? Well, W has to be less than 33.33. So could W be 33? Of course, right? So W could be 33. It couldn't be 34 because that would be greater than 33.33. So that would be your answer. Okay. And then I want to do page 123. Two-part inequalities, number 1. It's a little bit longer video, but this is a longer packet. So let's see how you would write number 1. So you look at the letter in between. So you're going to say that N is greater than -5 or less than 8. N is greater than 5 or less than 8. That's how you would read that. Number 4, there's an or. So this is considered what you would call an and equation. And this one by number 4 is considered an or equation, which it actually has the word or in between there. So how would you read this? Well, you would say that P is less than -3 or P is greater than or equal to 5. And why did I say or equal to 5? Because there's a little line under the greater than sign. So that's how you would read and write those. Okay, let's clear that. We are almost done. Let's look at page 124. And we have number 5. If for each inequality, 3 values are given, circle yes if the value is possible value for the inequality, no if it is not. So we have to read this as y has to be greater than -2 but less than 5. So 3 would fit within that. It's greater than -2 but less than 5. -2 would not, because -2 is equal to -2. And C, 0 would fit within that as well. So that would also be a yes. Let's look at number 10 here, way at the bottom. N must be less than or equal to 1, or N has to be greater than or equal to 5. So if N has to be less than or equal to 1, -1 fits that, right? That's less than 1. Is 0, is that less than 1? Yes, it is. And what about 5 3/4? Is that greater than or equal to 5? Yes, it is. So all three of those would be a yes. Okay, let's look at number 12. They want us to write the inequality graphed on the number line. So when you have a number line with a line and two circles on either end, that's going to be an and equation with the variable in the middle. So values for r, so r is going to be in the middle, and then we have to look at either endpoint, the lower parameter and the upper parameter. So 1 has a circle, a filled in circle, so r is going to be greater than or equal to 1. And the upper parameter, it has an open circle at 3, so r is going to be less than 3. So that's how you would write that. Number 13, that's going to be an or situation. Whenever you have two lines going in opposite directions, not including all values, that's going to be an or. So we look at -2, and that's got an open circle, so we know that y is going to be less than -2, or look at the second arrow there. We see a colored in circle at 2. Y is going to be greater than, that's supposed to be a y, greater than or equal to 2. So that's how you would do that one. Okay, let me clear. Let's look at number 19. And I'll set up number 18 for you too, but let's look at 19 first. The perimeter of DEF is greater than 102 inches, but less than 119 inches. So that's our parameter. The perimeter, whatever we're going to put in the middle here, is going to be greater than 102. It's our lower parameter, but less than 119. So that's our upper parameter. And then our equation for the perimeter is to add all sides. So we have 38 plus 25 plus C. That would be adding all sides. So I'm going to combine 38 plus 25 and get 63 plus C must be the perimeter. So now I solve for C. Now you can look at this as two different inequalities and solve it that way. And that's what I would do. So I'm going to just make a little bit of a space here. Hopefully that's enough to solve it. So my first one that I'm solving is 102 is less than 63 plus C. And my second equation is going to be 63 plus C. And let me just make another box here. Is less than 119. So we're going to solve both inequalities. So I see that I've got a 63 added, so I'm going to subtract 63 from both sides. Those cross off. I'm left with C is less than 102 minus 63. 10 becomes a 9, 12, 11, 10, 9. 9 from 6 is 3, 39. And on this side, I'm going to subtract 63 again. But this time, I'm going to be subtracting it from 119. Those cross off. I'm left with C is less than 9876, 11, 10, 9, 8, 7, 6, 5, 56. Okay, and then if I were to write my inequality, I would then have to write letter A as C in the middle. And the lower parameter is 39. C must be greater than 39. And C must be less than 56. Sorry for the messy writing there. My mouse seems to be sticking. If C is a whole number of inches, what is the smallest value C may be? Well, it has to be greater than 39. So the smallest value that C would be 40. So that's how you're going to tackle those problems. Okay, and then I just wanted to look at 18. I'm not going to solve this one for you, but I'm going to show you how to set it up. So each day, 5% to 10% of the 2,000 students who attend Hoover High School are absent. Write an inequality that describes the number of students, N, who are absent on an average day at Hoover High School. So we know we have to get the lower parameter, which is going to be 5% of 2,000 or 0.05 times 2,000. That's our lower parameter. And the number of students is n. They're going to be greater than the lower parameter, but they're going to be less than the upper parameter, which would be 0.10, 10% of 2,000. So then you would just calculate those values, and that would be your inequality. Okay, and then I think the second part tells you to solve for it so that you know the number of students. So then you would solve just like you did for number 19 that we just did. So let's clear that. And the last part, I'm not going to go over, it's review. So you will be working on inequality review, all the things that we've just covered. So I hope you have a good day, and we'll see you next time. Bye.